Hey everyone, and welcome to Developer Tea. My name is Jonathan Cottrell, and in today's episode, I continue my interview with Kalid Azad. Now, if you missed out on the first part of the interview, make sure you go to spec.fm to listen to that first part, and to make sure you don't miss out on future episodes of Developer Tea, go ahead and subscribe in whatever podcasting app you use. Thank you to today's sponsor, DigitalOcean. DigitalOcean is the fastest growing cloud hosting provider, and for good reason. We will talk more about what DigitalOcean provides to you as Developer Tea listeners, on top of what they normally provide, which is an incredible service. Now, I asked you guys before to tweet at Rachel Smith when she was on the show, and so many of you did that. It was such a cool thing to see so many people listening and appreciating Rachel for coming on the show. I'd like to ask you to do the same thing with Kalid. His Twitter handle is at BetterExplained. That's BetterExplained. Tweet at Kalid and let him know when you have an epiphany during this episode. I had quite a few when I was listening to the show, and I'm actually looking forward to listening to it again when it airs. So go ahead and tweet at Kalid because he would definitely appreciate hearing from you. Now let's go ahead and jump into the second part of my interview with Kalid Azad. So I want to talk about Better Explained kind of more explicitly now, because we've talked about learning, kind of we jumped straight in, and great discussion. I want to see how you apply this, because Better Explained is a really effective platform so far. You have over 400,000 monthly readers. That's a huge number of people that are interested in what we've already described as kind of this otherwise kind of cold thing, right? And so I want to talk to you about a couple of different things. First, we already alluded to it previously, which is I guess it's called the ADEPT model, the analogy, diagram, example, plain language, technical definition. You have this on Better Explained, and that to me was such an enlightening concept. I want to talk about that. I also want to talk a little bit kind of about your background, but how you mine out these analogies, how you find them. If I'm somebody who's coming to the table and I don't have a Kalid to tell me what the analogy is, how do I find it in some material? What do you have a process for that and that kind of thing?
Great. Yeah. No, thanks. I've been fortunate over time. The site's basically it's grown, and I think one of the lucky things for me is because math is fairly static in a good way, in the sense that, actually in the developer ecosystem. So I'm a web developer actually by day as well. And the issue is, there's new libraries, new frameworks. So your knowledge, the general principles of programming stay, but then the specifics of a library, you have to kind of keep up to date. Luckily with math, I have articles. Some of the most popular ones are like 8 years old, but it's okay because the math hasn't changed in 8 years.
Sure.
Like a number is still a number and so on, or like the theorem's still a theorem. So if you can write something that maybe has a good analogy or a good diagram for that topic, then it'll stay relevant. So I've been fortunate that math was the thing that I wrote about versus I do have some programming things, but those ones, like I have some old Rails tutorials, but of course those are, 5 years out of date now. So the math stuff seems to be the ones that are more sticky. But yeah, in terms of learning, I think I guess the largest skill is really just recognizing when something clicks or doesn't. And it kind of comes back to that taste element, just knowing when something tastes good or not. And so for me, I realized, okay, well, something will click with me if I can see the big picture, at a kind of a blurry level, 50,000 feet. And then I sort of zoom in gradually and sharpen in the details. And actually, this is, I call it sort of the baseline versus progressive model. And it's a nice little programming metaphor as well. I don't know if you've seen, or you probably have, back in the old dial-up days, sometimes, you'd be like downloading an image and it would kind of chunk in slowly. And there's sort of two ways that it could be encoded. Like one is where it just go top to bottom. And so it's kind of scanning and it kind of fills in perfect detail from top to bottom. And the other is it's sort of sending these updates. So it's kind of a blurry version of the full size, and then it gets sharper and sharper and sharper. And eventually it sort of snaps in. And you sort of see that on YouTube, if the resolution is being changed. And so I realized for myself, I learn best when I have that kind of blurry version that sharpens up versus kind of that perfectly accurate version, but you're only getting the first 10%, the first, the next 20%, and so on. So I need to see the big picture and sort of sharpen it up. And so the adept method is basically that, where you're starting with the blurry version and then you gradually introduce more detail until you end up on the most technical version. So an analogy is like a very blurry, it's inaccurate, but it's okay. It's kind of a lossy version of the big picture. And then you have a diagram, which is a little bit more accurate. You have an example. Then you have plain English, which is kind of a kind of a friendly description, and then you have the technical description, which is kind of the most accurate. And so I need to be kind of walked through those steps instead of starting with a technical definition. I feel like most people or most classes, they will be friendly, quote unquote, by very slowly walking through the technical definition. And that's friendly in the sense that you're at least understanding that it is complicated, but you're still sort of taking somebody. It's kind of like saying, hey, we'll go for a marathon. Like a marathon is like the end result of like all this training. So we'll walk slowly the 26 miles, which is, I guess, slightly more pleasant than running through the 26 miles, but it's still quite, it's still pretty brutal.
It's grueling. Yeah.
It's grueling. And my thing is like, hey, let's just have a fun run. Let's have like a 1K or 5K, and then we'll build up our kind of endurance there versus like going slowly through something that's still very kind of technical. So that's sort of the general approach. And then for me, I basically, when I find a new topic, so imaginary numbers is one that I like just because it's really confusing. If I'm studying a topic like that, I'll go on Wikipedia, not actually for the technical definition, just for images. I'll say, hey, are there any diagrams here? I'll go on YouTube, I'll look Google Images, and I'm purposely not trying to find super technical definitions. I'm trying to see, like, when people talk about this, hopefully they've been forced to make an image or two. And so I'm trying to force myself to find those images and diagrams and maybe try to get some rough intuitions out of that. And I sort of come up with my own analogy. And then I'll start reading the formal description to see how people are describing it. Yeah, I'm like purposely trying to shield myself from some of the complexity just to, I'm it's almost squinting and looking at the page. And have you heard of that? There's like a usability technique.
The squint test.
The squint test, exactly. It's like, step back across the room and can you tell what the layout is or what's the most important thing on the page? And, it should be colored differently or it should be, called out. And that's exactly it. It's like, if there's a topic, okay, can I squint at it and say, what's the most important key concept here? So for me, like imaginary numbers, they're usually taught in a very confusing and unintuitive way. The technical definition, it's like the square root of a negative number, which is mind-blowing, and people seem not to like the teacher will kind of say that and nobody will blink an eye, or the students will blink and the teacher says, oh, it's just the definition, you have to use it. And I'm saying, nope, that's not good enough. Like that isn't clicking. And so a better intuition is that an imaginary number, it's almost like a rotated number. So it's like a regular number line kind of goes east to west, let's say. So you can go east to west, and imaginary numbers go north and south. And so it's like, oh, okay. It's like a second dimension. It's like, yes,
yeah.
Exactly. It's like, oh, okay. But to get there, and this is kind of the tricky thing that they don't mention, like to go, if you're going east and west and you want to go north and south, you need to rotate. You have to take a 90-degree turn. And so when people say that like I squared is -1, basically what they're saying, and see that's such a technical definition, I squared is -1. My analogy is that, okay, if you're going, east and you take two 90-degree turns, well, now you're going west. It's like, oh, okay, yeah, boom. So I was going one direction, I turn once, I'm going north, I turn again, I'm going west. Oh, wow, okay. So you can go backwards in 2 steps. And that's essentially what an imaginary number does, is like it says you can get to a negative number in 2 steps if you allow yourself to rotate. It's like, oh, wow. And it's like, oh, okay, and that's a neat analogy. And then suddenly you're thinking, wait, so could I use imaginary numbers like to model rotations? Like if I'm making a video game and I want things to be rotating, isn't it nicer to use an imaginary number to represent that because it's already kind of knows about rotations? So yeah. And so there's actually people use imaginary numbers, and there's actually extensions because those are only 2 dimensions. You want a few more. And so they have these things called quaternions, which they use in like Unity. Like a lot of graphics engines will use these kind of super imaginary numbers that can track more dimensions. And that's how they do the rotations. It's like, whoa, that's amazing. And the thing is, that's like an analogy that you figured out just by playing with that exploration. It wasn't like in the Wikipedia article down at the bottom, it'll say, oh yes, and there's these extensions that can do these other things, but they don't really call it out explicitly. They kind of like that connection isn't really made. And so I try to I guess mine or sift. I feel like a like kind of like a gold prospector, sifting in the river, like hoping something sticks in the pan. And I'm just looking at images, looking at PowerPoints, PDFs, just at a high level, trying to get images. And and sometimes I make analogies that don't work. I'll make an analogy and it doesn't make sense, and that's okay. Okay, I'll go to the next one. But once you find one that does work, suddenly it's, oh, I love that feeling, like the aha moment. It's so invigorating. And so for me, I know that really motivates me. So once I find it, then I get excited. I start thinking about it more, and then eventually I make an article and I write it down. But yeah, it's the process is really trying to, at a high level, get the diagrams, the analogies, and then slowly introduce the technical pieces.
Yeah, and I think our brains are already hungry for this. I think we naturally want that high level overview before we jump in anyway. I don't think I know anybody who doesn't want to kind of my dad says, get the gist. And before we watch a movie, he wants to know what the gist of the movie is. So he can decide if he wants to fall asleep during the movie or not. So, but no, I think we want that overview to kind of learn about something from that. What is the end game here? Like, what is this? How does this fit in? And I love the idea of finding these kind of modeled concepts and then realizing that you had this realization, hey, we can use imaginary numbers to model rotation. And then
Yeah, exactly. Oh, it's the best. And actually, that's it makes me like beam with pleasure. So I have this imaginary number article, and it basically, I just mention rotations. And actually, I don't mention the 3D or 4D, like the quaternions. They actually have 4 dimensions, but you can do rotations in higher dimensions. And I don't actually say, oh, and this is what you're going to do with it. A lot of people in the comments ask, hey, wait a minute, can we have more dimensions? And I'm like, yes, you can. And like, here's how they can be used. And it's sort of like purposely letting the person, you don't want to spoil the joke. Like if you're a comedian, you don't want to over explain the joke, right? You just want to have the punchline and the person gets it and they laugh. It's not, okay, and here's what's going to happen. It'll be a crazy scenario. Da, da, da. Like you need to have that kind of a little bit of a fun game element. And I feel like with teaching, we sort of miss that sometimes too. Like we don't let the person make the connection. We're sort of, this is, again, I think of these aliens. I try to, when I can, like look at things from like a kind of objective like perspectives. Like if an alien came to Earth, and so if an alien came to Earth, it would look around and see, oh, hey, everybody's chewing their food. Like we waste, an hour every day just chewing. Maybe I should, if I'm an alien, I should just like blend people's food and inject them with it. And it's like, actually, part of the fun of eating is chewing. Like that's actually, it's not work, it's actually enjoyment, and trying to quote unquote optimize that, because it's an inefficiency, right? Like we could eat our meals in like 2 minutes if you just injected it, or you had like a liquid diet or something. And it's kind of like, it doesn't, part of the fun is actually in a little bit of a struggle there. And it's not even struggle, it's just, it's effort. And I feel like with learning too, like trying to smooth everything over, trying to make it a perfect path, trying to explain every conclusion, ahead of time, you're sort of removing that wonder and that joy of discovery. And, like the creator or the inventor of the math, they didn't know what it was going to be. They were just, I mean, can you imagine being the first guy to figure out counting? Like, I actually know, I know how many sheep I have. Yay. Like, whatever it is, like that was such an awesome idea. So like, don't, like let people enjoy it a little bit. And I feel, there's sort of, and again, that's kind of the art, entertainment and art, they sort of have figured out how to get people to want to participate in something. And I feel like science and education.
That's so true.
Yeah, there's a lot to learn
That's so
there.
true. I want to go back to your adept model. By the way, did you come up with this model?
Yeah, well, it's a general approach, I think. I just
Okay.
put the acronym in. I'm really not a fan of, well, I don't like forced acronyms. So it actually started with like ADE. And I was like, oh, analogy, diagram, example. And then I realized, oh, but then I have the technical definition, and then the plain English is sort of a bridge. So the one, I guess I made up the acronym, but I didn't try to like. I really don't like it when they force.
You don't want to push it too
I don't want
much,
to push
right?
it exactly.
Yeah.
It's like in programming too, they have a lot of there's all these in jokes and things like the recursive acronyms and so on. But
Yeah.
this I basically people have been doing. I think even Confucius. There's a quote about, it's like, tell me and I'll know, and it's like, show me and I'll see, and like let me experience it and I'll understand. So it's like an ancient concept, and I just put my version of it on there, but it's an old.
Well, I want to return to it because you said something that was really interesting about, you know, introducing the fun run first and then, maybe moving up to the 5K, whereas, the traditional approach is to walk somebody through this marathon, right? It's so interesting because basically what you're doing is you're flipping this on its head, where the traditional approach is to start with that technical definition and then derive from the technical definition applications, right?
Exactly.
So you have, word problems that once you've learned in class all of these kind of formal ways to approach the word problem, then you're presented with the word problem and you're set and somebody says, "Okay, here, use these tools to solve that word problem." I wonder how much of a difference it would make to that class if we just simply switched the order and we said, "Okay, here's the word problem. Here is the application in its natural form. Like, this is something that you could imagine happening in a real world scenario, right? And then you say, okay, now you don't know how to solve this yet. We're going to show you a pathway to figuring out how this word problem plays out, right? And typically, I mean, it's a little bit more difficult to solve or to say that some of the more complicated aspects of math can be, brought down into a word problem, and then that word problem makes it all the way through as the final piece, the final proving piece. But certainly this idea of coming up with a analogy or even something that directly applies, I wonder how that would change the way that people learn if they were to see the problem or the application first.
Exactly. And I think it's way more interesting. It actually, I keep looking for all these stories and metaphors. There's some, in a similar way, there's a story about a climbing instructor. If you want to learn rock climbing, most people, you go to a class and you'll spend like an hour learning knots and how to tie things and ropes. And I mean, that's important. But there's actually a guy who's an instructor. He's like, okay, just go on the wall and just try to climb around a little bit. Like, don't go too high, just climb. And people will do that for about 10, 15 minutes. They get tired. And then finally he says, okay, now you've tried that. Here, let's talk about a few things. Like, you got to use your legs. Like, most people try to use their arms and your arms are weak, your legs are strong. Okay, you don't want to be hanging off the wall. You want to be close to the wall because now you have this like lever action. So basically, people tried it and they understand the problem instead of ahead of time. Okay, use your legs. Okay, be close to the wall. Okay, do that. Like, basically, you're kind of giving people details about a problem they don't even understand yet. And
Yeah.
so, like, it's
Yeah.
really it's not vivid in their mind. And I think that's exactly it. Like, when you have a problem, I love the idea of giving somebody. I mean, math. It can be its own art form, but often, from the practical point of view, there are applications. But the neat thing is to have a problem that you can't do, and then you learn a way to do it versus like being given this hammer, like, give somebody nails, give them a board and they're trying to put it in. It's like, oh, this hammer is really cool. Oh, wow. And they might even play around. They're like, oh, wait, let me get a rock. Okay, let me hit the rock. And then you say, okay, well, imagine taking that rock. It's really hard to hold, right? Like, a rock is really round. So like, maybe put it at the end of a stick because a stick is easier to hold. And okay, and that's basically what a hammer is. It's like a rock at the end of a stick. Oh, neat. And it's much more like natural versus like, here's this perfectly pristine tool that's been machined and everything. And that's exactly it. I think for myself, I found it so much more interesting, and you sort of can engage people. And also, I mean, people find different techniques. Like, I mean, this is a kind of a general thing too. As a teacher, I see myself, I don't even like the word teacher so much. I'm more of like a guide, I guess. I'm like a guy, I want to go up the mountain. Hey, there's a nice view up there. Like, let's go explore. But on the way, maybe you'll find a better path. Like, this is my path up there, but maybe you'll find a different path, or maybe you'll notice something along the way that I missed. And so, um, I think there's this kind of not paternalistic, but it's sort of like the teacher knows everything and the students don't know anything, and it's time to fill up the student's mind with the teacher's knowledge, versus kind of an exploration or more like a coach, where it's like, hey, we're like doing this training session, and actually, as a teacher, it'd be nice if you're doing the exercises too and you're sort of learning things. And a lot of people say they only learn something when they have to teach it, and oftentimes that's because it's your second or third visit. And it's really funny, like, most people wouldn't claim to understand, let's say, Shakespeare. Like, let's say you read Romeo and Juliet one time when you're 14. It's like, okay, I know Shakespeare. It's like, no. Or I even know that play. It's like, no, I read it once when I was a kid. If I read it again, I'm sure I'd get a lot more out of it. And so I feel it's a second, third visit that, if you're allowing yourself to kind of be open and, empty your cup and, fill your, I don't know if you've used that. Do you know that koan about like the master, like the Zen, like the professor and the Zen monk?
No, I don't think so.
Oh, I think it actually fits with your podcast. So
Oh,
basically,
perfect. Here we go.
exactly. So there's like a kind of like these old Zen stories about a famous professor who knew all about different religions and things, and he came to Japan and he was going to study like the Zen, I guess like the Zen religion. And so he's explaining to all the monks about all the history of the temple and all the things he knew. And he went to go sit down with this elder monk, and the monk offered him some tea, and he said, "Oh, sure." So the professor put down his cup, and the monk filled up the tea, and it was filling. Then it got full, and the monk kept pouring, and the professor said, "No, no, you can't. It's full. It's full. No more will fit." And essentially, the monk said, "Well, just that's like your mind. Like your mind, just like this teacup, it's already filled with what you think you have. You need to empty it in order to get some more in there." And so it's sort of that like humility, but humility makes it seem a little bit more like you have to be different than you are. It's more just open exploration. So again, yeah, being a teacher and just exploring, and who knows, like you'll find new things. I mean, I get a lot of teachers who they say, "Oh, I never thought of it that way," or "that diagram, I've never seen it." And that's great, because now to me that that teacher can take it and modify it. I have this analogy about sort of being like a grocery store. So I'm a grocery store. I have apples, I have tomatoes, I have all these ingredients, and you can eat them whole. Like an apple is delicious by itself. Or if you're a teacher, you can take this apple and make a pie out of it. And I don't know how to make pie, but like, hey, you made a lesson for your students based on what I think is a high quality ingredient. So hopefully it tastes great and the kids like it, and it's different from what I had too. So
Yeah,
yeah, it's more of
that's
a
great.
playful thing versus this kind of very prescribed thing that we're used to.
Yeah, I love the university model is very much this way. If you have, especially if you've experienced going for a post-grad degree, which, most people don't these days, and there are many reasons not to, and there are some reasons to experience that post-grad degree. One of the things that I loved about my experience in university was that the professors, they studied with us, right? They did research with us. They did research projects with the students. And it's very different from what you're saying, this idea of taking the knowledge out of my brain and transplanting it into your brain. That wasn't the goal. The goal was to say, okay, here are the methods that I use to research, and now let's find new things together. And that was an amazing experience because, it didn't leave this mark of like, well, I've blazed the trail and now you can follow behind me. It was more like we're blazing a new trail together.
Exactly. And actually, a fun example of this, basically, once this happened to me, I threw out any notion that I knew anything. I basically, I tried to empty my mind and empty the cup. So, like if you think about the concept of a percentage, it's something that we use every day. Percentages, we probably see it, 100 times a day, poll numbers, interest rates, everything. And so, I'm pretty sure, or at least I thought that I knew pretty much everything there was about percentages, right? Like we've been using it since like, elementary school. We know it pretty well. But there's something I think, at least for me, that I missed the whole time, is that you can actually swap the numbers in a percentage and you actually get the same result. So for example, if somebody asked me, "Hey, what's 16% of 25?" I'd be like, "Oh, 16% of 25. Oh, hold on." And if I didn't have, it's like, okay, let me get the math. Okay, divide by, and it's a little bit cumbersome, right? 16% of 25, not fun to figure out. But if somebody said, "Hey, what's 25% of 16?" I would just, 4. Yeah,
Yeah,
it's a quarter.
yeah, sure.
It's easy, right? So wait, one was hard and one was easy, but it's actually the same problem, because 16% of 25 is 16 divided by 100 times 25. And 25% of 16 is 25 divided by 100 times 16. So
Oh, wow.
so like either way, yeah, isn't it crazy? So it's like A% of B is the same as B% of A. And
I've never heard that before.
isn't it crazy? And I just thought, it was basically, I was literally doing that problem out, and I was writing like 16 divided by, because I had to do that, 16 divided by 100 times 25. I'm like, wait a minute, I can just put the divided by 100 on the other side. Oh, wait, that's like, and boom. And so after that happened, I was okay, because, and I would have bet somebody $100 that, I think I know everything about percentages, especially something that obvious. Like there's only two. It's like, actually, I love it. You know what? We're programmers. There's a percentage function. Hey, it turns out the order of the parameters doesn't matter. Fancy that. Fancy that. you know,
So if you're doing any logic to order your parameters correctly, you can just drop it all
you
together.
just drop it all together. Exactly. Like who cares? And maybe, or if you're calculating a tip, I mean, and this is kind of I guess the joke, there's a 50% chance that one way will be easier than the other. So maybe like you're just looking at some numbers and you just want to make a quick mental estimation. Well, just flip it around. Maybe it's a little bit easier. Maybe one number's, and it's like, oh, okay, you're just eyeballing it. And it's like, holy, like, and a percentage is like, again, most people don't like math that much, but I think they agree that percentages are probably pretty useful.
Pretty easy.
Yeah, pretty
Yeah.
easy. And, it's kind of necessary to probably survive in modern society to some extent to know what a percentage means. And it turns out we didn't actually really know what it meant. Or we didn't really, like, we missed
We
it the
didn't
whole
follow
time.
it through. We didn't follow all the logic
All
through.
the logic. And it's like, oh, wow, that's crazy. And so after that, I was thinking, okay, man, like, what else have I missed? Like, I'm completely willing to, oh, actually, this is a fun one too. Again, for the programming audience, all those like off by one errors that you get in for loops, like you have like array indices and like you're like this like the length of the array is like -1. And like, there's all these little gotchas that deal with counting.
Sure, because of zero index, right?
Zero index, exactly. And so as a programmer, we're kind of aware of this a little bit. Like we sort of know you have to sometimes watch out when you're counting in loops and with like, memory addresses and things. We're kind of like, we kind of know there's something going on and we're suspicious of them. Like, so we always check our bounds and things like that. But there's sort of this general concept. It's called like the fence post problem. And essentially, if you have a fence with, let's say, 10 pieces, like 10 lengths of fence, there's actually 11 posts. Because you have to kind of cap the ends. So you have like the first piece and the length, and then basically like, and it's kind of cool, like if you draw it out, or even like a fence with one piece, right? Like a fence with one piece has two posts. And so it's like, oh, wait a minute. So when you're counting, sometimes you're counting the fence pieces
Rather than the posts.
rather than the posts. And a good example actually, and I love this, like it's like one of those things you tell the kids, but it actually works on adults, is if I say, hey, can you do some chores for me? It's like, okay, fine. So you're in an office building. I want you to mop floors 8 to 11 from 8 a.m. to 11 a.m. It's like, oh, okay. And so most people say, oh, I have like an hour per floor, right? Because it's floors 8 to 11 and it's 8 a.m. to 11 a.m. It's like, oh, actually, floors 8 to 11 is 8, 9, 10, 11. And so that's 4 floors, 8, 9, 10, 11. But 8 a.m. to 11 a.m. is only 3 hours.
Yeah.
So it's like, whoa. So what happens is some things in life are counted as points and some things are counted as spans.
Units.
As
Yeah.
units, exactly. And so what happens is sometimes if you're doing subtractions or you're comparing things, you're getting those off by one errors. And it's essentially because something was counted as points, something was counted as spans, and it's this fence post issue. And it's so funny because we learned to count, again, in like elementary school, but nobody told us like sometimes it's like, or date ranges. Like for example, if you're out of town on vacation from March 8th to March 11th, you're actually gone for 4 days.
Rather than 3. Yeah.
Rather than 3. But if you just look at it, you're like, oh, he's out for 3 days. He's actually out for 4 days.
Sure. Yeah.
And it's like, whoa. So like, it's crazy. And so this happens all the time. And we just think we're being foolish. Like, wait, you just subtract it and you get the wrong answer. And it's like, no. It's actually 8, 9, 10, 11 is 4. And it's crazy. Like,
have you seen that? This is exactly that issue. There was a kind of I don't know, it was somewhat famous thread on, I want to say bodybuilding.com or something.
Oh, I heard about that. That's right. It's it like 7 or 8 days in a week or something?
Yeah. It was on average 3.5 times going to the gym because they go, Monday, Wednesday, Friday, and then, I don't know, Tuesday, Thursday, Saturday, or something like that. Basically, it worked out that they go 3.5 times per week because they just alternate days, right?
Yeah.
And so naturally, you're doing once every other day, and there's 7 days in a week. So you're doing on average 1 out of 2 days, which is 1/2 of that 7 days. So the average works out to 3.5. And the thread basically, and I'm probably not going to include this in the show notes because it's just not, you can Google it if you really want to see it. But the thread basically is people going back and forth, getting really angry that you can't go to the gym 1/2 time. It's just, it went on for probably 40, 50 pages on this forum.
Oh man, and I just imagine these guys like super like amped up and angry. Oh man, it's pretty common. This sounds like something out of Futurama or something.
Oh yeah. It was amazing.
Oh man, that's funny. I think I heard references to it, but I'll when I have some time to kill, I'll go check that out.
It's one of the I would imagine that if you found like a Reddit thread on, Hall of Fame of the internet, that it's probably in there somewhere.
Oh, that's awesome. Yeah, and it's funny because like, and now suddenly the math is interesting to people, right? Like, wait, what does the average mean and this and that? So, like, I think that, there's definitely ways, hey, I'm not too particular about the method. So if that's what it takes to get people interested, okay.
Yeah, sure. You jump on that thread and be like, hey, by the way, everybody, I have an answer to this. You can understand this.
Yeah, the fence post problem. Yeah, exactly. So it's kind
That's great.
Yeah, I mean, no, but that's it. Like you can, and a lot of things with math, it's not like you're trying to force fit it into life. You just sort of have that concept and then it'll just pop up. And, a lot of people with math too, they're like, oh, when am I going to use this? And to me, that's a little bit like saying, why should I learn the word gigantic? Like, when am I going to use the word gigantic? It's like, well, it's kind of nice to know that it exists. And sometimes it might be really fitting. I mean, you can't just say really big. Like you can get through your entire life saying really big and never saying gigantic, but there's sort of a nice appreciation for the fact that this is sort of an existent, it's a concept. And over time in math, we've kind of tuned it down to the things that we think are actually useful. So we're teaching algebra, geometry, like things that have been useful for thousands of years. We're not
the cold practical things.
Yeah,
right?
Exactly. Things that like the math that wasn't that useful has been like kind of, it's faded away to some extent. So yeah, this is sort of what's been distilled down. And yes, but exactly. So like you're not like, so maybe the bodybuilding thing or like the days of the week or you're counting. And it's funny actually for me now I have like a set of kind of gut checks or like heuristics. So if I'm ever doing a subtraction in the back of my head, I'm saying it's funny. It's not even that I know which one to use. I'm just like, let me just do a quick example and make sure I got it right. So if somebody said, 8 a.m. to 11 a.m. and you have floors 8 to 11, I wouldn't just think 1 hour before. I would have to say, wait, I think it's an hour before. Let me just double check. Oh, it's not. And then I'd have to actually, like I've learned to kind of check myself and, have those little debug, kind of those assert statements actually, like in my logic. And I'm like, okay,
testing yourself.
Testing myself. Exactly. Just because I know how easily it is to get, or how easy it is to get tricked on these things. Yeah.
Today's episode is proudly sponsored by DigitalOcean. I was at FluentConf this past week, and I saw Wesley Hales. I actually tweeted about this. Wesley Hales did a demo. He demoed his application. It's called SpeedGun, and he was able to deploy his application in less than about 2 minutes, and he used DigitalOcean to do it. That was just a testament. One of the many use cases for DigitalOcean is Docker deployment. It went up in literally less than 2 minutes, and he did it live on stage while he was giving a presentation. This is a testament to the reliability and the efficiency of DigitalOcean. DigitalOcean is the fastest growing cloud infrastructure provider because they are laser focused on their mission to create simple and elegant solutions for developers and development teams. Now, it's incredibly easy to deploy, as I just now said. It takes just a few minutes, and you can deploy with pretty much any kind of platform that you're used to using: Node.js, Rails, Magento, Docker, and you have access to these things, root access, and you can spin them up and take them down through a control panel. Now, DigitalOcean is built to scale. You can obviously scale your applications manually, or you can use their API. Now, that mixed with the fact that DigitalOcean is highly reliable and available, there's data center regions around the world, and the fact that it's straightforward pricing, you only pay for resources that you actually use by the hour. There's no setup fee, no minimum spend. This is kind of a no-brainer for you as a developer. Now, if that wasn't enough, DigitalOcean has been kind enough to provide Developer Tea listeners with a special code that gives you an entire free month on a gigabyte droplet. That's a gigabyte of RAM that they're talking about there, a gigabyte droplet. And all you have to do to get that gigabyte droplet is use the code DeveloperT at checkout. Thank you once again to DigitalOcean for sponsoring DeveloperT. Of course, you can find the link to DigitalOcean as well as that special code at spec.fm. I love this concept of finding the problem first. And this is really why, on this show and many other programming related podcasts, when people ask, how do I learn? What is the best route to learn? So often you hear the answer, make something.
Yep.
Like go and actually build something. And it's not because, first of all, we're being lazy, right? The podcast hosts that tell you to do this, another great example, Shop Talk Show, Just Build Websites. It's not because we're being lazy. It's because this is truly the way that you learn best, is going and seeking out the problem, the actual problem, rather than trying to learn all of the solutions up front and then cherry picking from your list of solutions to solve the problem with. Learn the solution by finding the problem. Learn the solution by going out and discovering something where that solution should go. And then you can kind of, find your way backwards. And it helps to have some base level knowledge, and it helps to have a go-to resource, for example, a mentor, or maybe a couple of books that you can reference. But if you're going to learn, for example, JavaScript, you're going to learn much better if you go and build something with JavaScript and then refer to the reference book, as you're building it, rather than trying to go through the whole reference book and then going and building something.
Exactly. It's really, really hard to kind of walk through the official description without any kind of real world thing to ground it. And actually, in that way, I have some side projects that basically I use. So if I'm trying to learn like React, for example, it's like, hey, okay, this project was written a while ago. Let me just try to refactor it into React, and then I'll learn about React basically
through that refactoring,
exactly. And it's hard to say, some things maybe you're casually interested in, but it's way more fun when you can say, I applied this pattern, or I used this library, and now my project got way cooler or way easier than it was before. And that kind of before and after, I think is pretty powerful as well. It's the same thing with like the rock climbing, like, you kind of struggle, and it reminds me a little bit of like jujitsu, or like the martial art, but basically it's all about using leverage and kind of, even if you're smaller, you can still use leverage to lift somebody who's bigger. And the thing is, if you just wrestle somebody without knowing anything, you're just tiring yourself out and you're basically exhausting yourself. But suddenly you learn one little thing, like, if I push on their hip this way, it's really easy to move them. Suddenly it's a lot of fun. It's like, this thing, like you remember how difficult it was, and now it's a lot easier. And so I think the same thing, like with your project, as you get better, you remember how cumbersome it was. I think, I remember the first time I learned CSS, like in high school, like learning HTML, and you're putting like font tags. Like this is way back in the day. Like you're putting font tags in, and like you're making things manually colored. And then you learn CSS, you're like, whoa, I can change the whole look. Like I changed this one file and I didn't touch my HTML and it looks completely different. Whoa. And it's amazing. And I think it's a little bit hard to appreciate that sometimes unless you struggle a little bit with the old.
Yeah, I agree with that. I think actually Sandy Metz does this very well in her book, and I've referenced it many times on the podcast before, but she introduces the concept very well up front, and often she'll end up writing, refactoring code and writing it in such a way that you start feeling the pain, right? So like it starts getting a little bit out of control, and but she kind of trudges through, and then she says, now let's look at this code. Does this look great? Probably not, but here's a way that we can make it look better, and just this constant refinement and introducing new concepts through that, exploring the problem first. She does that very well. The book is called Practical Object-Oriented Design in Ruby, but really it's just a lot of Sandy's rules and experience that she's placing into the book. Another thing she does, by the way, we mentioned a squint test for usability earlier. I feel like it's worth mentioning. Sandy also does squint tests on code to see if the code if there's anything that's out of shape, right? So if there's any one really long line or one really short line, or if there's a block of lines that are all the same length. Some of that could cause, she tells you to look at it and see if there's a better way to write it. And typically, the best code basically follows a simple contour without any outliers.
That's a great. I really like that. I'll have to check that out because one of my philosophies too is you can't just show somebody the right result. You need to kind of show them the thinking process that got you there,
The
the
motivation. Yeah.
motivation, and also like the judgment. Like she said, oh, like it sounds like, oh, hey, I started with this function or this, this program, and it's a little bit unwieldy. And as you can see here, we're repeating ourselves, or it's a little bit cumbersome. And let's refactor that and make it better. I feel this is actually what math unfortunately suffers from, is that you have this kind of golden or this like bright jewel element where from like it's like this perfect jewel of an equation, and you don't realize that this equation was arrived at through like a process of struggle, or this is like a cumbersome way to write it, let's simplify it, let's smooth it out. And because really the goal isn't necessarily to get to the end point, it's to kind of experience it's like when you do a push-up, like the goal isn't to actually move like your chest 6 inches. Like moving your chest 6 inches isn't the point. It's really about your arms lifting a weight in the struggle. And so I think with math, it's like, oh, I got to the end result. It's like, well, yes, but unless you understood how you got there, it doesn't matter. Like we have computers that can find the result, the answer. We don't need humans to do that anymore. I want to make sure that the path that we took is it really sinking in.
It's like having that apple ingredient, like you were saying earlier. You have the apple, and now you can mix that with other new, interesting, exciting things and make stuff that nobody's ever had before.
Exactly. And really, it's, if you understand, this is, I guess, a little bit metaphysical, but if you understand the nature of an apple, like an apple is sweet, it's crisp, it's kind of juicy, it's got these attributes. And now the reason you pick an apple in your pie is because, oh, the pie, I want something juicy and kind of crunchy in the pie. And so that's why, like,
Yeah, it's not its appleness, it's its crunchiness.
right. It's a crunchiness, right? Because you would never make an orange pie. But like an alien who say, why not an orange? It's like, well, an orange is like citrus, it's kind of sour, it's like squishy, like it just doesn't work. And
Well, the aliens blending all of that stuff together anyway.
oh, that's right, sorry. Yeah, they're just injecting you in the back room anyway, so but exactly. Yeah, it's really about like being able to look at something and kind of summarize it in your own mind. And I think that's sort of like the point for me of an analogy is that it's like, it's again, it's funny how many we use in everyday language, but we don't realize, like metaphors like, well, now it's like the ant and the grasshopper for saving, or, like eyes bigger than your stomach, all these, like we use so many kind of metaphors and similes in life just because it's so easy to, like, it summarizes the essence of the argument so quickly, or like slippery slope, or anything. We really can get across a huge, rich context with just a few words. And so to me, like once you have an analogy, you sort of summarize this, this concept, this equation. You can summarize it in 2 words, and now you can use it, and you sort of get the appleness of it. You kind of hold it in your hand. Yeah.
The kind of these key words that can anchor you back to that central idea of a more complex thing.
Exactly.
I guess that's kind of like a heuristic, I guess.
Mm-hmm. And actually, this happens in programming all the time too, where you end up chunking concepts, and then you can use those chunks. And I mean, that's kind of programming, right? Like you have a lot of statements, you put them into a function, and then you have a few functions, you might put them into a module, then you have some modules, and you're sort of building up something. So, we might use an acronym like MVC, and it's 3 letters, but now you understand, oh, okay, this program is broken into tiers, and there's like a model, and this maybe, there's a view and things like that. But you've basically summarized something that could be pretty complicated into a few letters. And now you can say, oh, we have MVC, and we have a REST-based API, and suddenly, like, it's a lot of it's a lot of detail.
Tons of things.
Yeah, tons of things that you've chunked it up. And my thing is, like, with math, like, when we have an equation, the equation is like this giant super, like the equation is literally the source code of like a library, but you don't want to think at the source code level. You want to think at like the function or like the behavior level. So it's like, okay, don't label it, even something like the Pythagorean theorem, that's like kind of a bad name in a way, because that's like saying the module that was written by Pythagoras. It doesn't it doesn't really tell what it does. It's like, oh, the Pythagorean theorem. How about like the distance theorem? Oh, that might be, so like, let's use the distance theorem here. Oh, okay, like that's a lot more kind of useful than this kind of name. So There's actually
It's
another
less memorable, but much more
much more
useful and
useful.
descriptive. Yeah.
Exactly. And now you can sort of take that concept and like you can almost pseudocode. Actually, I kind of do pseudocode math where if I'm trying to think about like I have this sort of analogy that math is it's kind of like software for your brain. It's like software that your brain is running. And
Yeah. It was
so
the first time I learned the word function.
yeah, exactly. Yep. Function, algorithm, all these words, they're sort of like from the math world where there's like, hey, yeah. And actually if you look at like f of x, like it looks just like it's like JavaScript. It's like you take a
Yeah.
parameter,
Or
return a
Lisp or
parameter. The
something. Yeah.
Lisp, exactly. And it's super terse. And the problem is like it's not like it's actually not well documented. It's not typed very well. There's a lot of overloading. Like it's not as clean. There's no like it's not as clean as a language, but the concepts are there. But yeah, you can really like you can take those concepts, you can chunk them, you can think at a higher level of abstraction, and you're not stuck in the source code. And I think a lot of people with math are used to having to memorize. It's literally like memorizing every feature of the API instead of knowing okay I can put data there. I'm sure there's a parameter to control the sort order. Like you don't have to memorize every little detail. You just know that you can look it up when you need to, but you need to be
Yeah.
familiar and comfortable with it. Yeah.
And really everything we've talked about today has been enlightening. I'm sure there have been quite a few of those of your trademarked aha moments there.
Yeah. And for me too, that's the thing. It's like my general approach, I guess, for people that are trying to learn or anything, it's really just find what lights you up. So for me, that aha moment, it gets me going. For someone else, it might be something different. But I think part of education, which I think is missing, unfortunately, in school, is teaching you to like the point of gym class in school should be to find a sport that you like that you can play for the rest of your life and enjoy. That should be the point of gym. If gym class is to teach you about physical education, the number one goal should be when you graduate from high school, you've at least found two or three sports that you think, hey, in my 40s and 50s, I want to play tennis or basketball or something. Because, it doesn't like running around and exhausting yourself for a few months when you're 18 doesn't really help your long-term goals.
Right.
And so,
Yeah.
and same thing for math, like cramming algebra and trig for a couple of years when you're 18 or a couple semesters when you're 18, it doesn't really help your long-term outlook on things. And so it's kind of like the newspaper thing. It's like the point of the first headline is get to read the first, like the point of the gym class is to find something that you care about. And the point of math should be to unlock that or find a way to unlock that excitement in yourself. That way you can always, if you need to, you can always learn something and you know how to kind of engage yourself.
Yeah, that's incredible. Hopefully I have a few teachers listening to this episode.
That'd be awesome. Yeah. And actually I'll send it around to some that I know too. So hopefully they'll
Sure.
make their own apple pie there.
Yeah. Well, this has been great, Kalid. I do have two questions that I like to ask every guest who comes on Developer Tea. And these are just kind of the Developer Tea branded questions at this point. The first one is, if you could spend 30 seconds with every developer, what advice would you give them?
Oh, good question. In your README files, start off with examples. So whatever modules you're making, please give me some really simple examples. Like whatever you're doing, just get to the point. Like don't use jargon. Just like whatever modules you're making for people. Like man pages and things are okay, but they tend to be pretty verbose. Like just make it usable for somebody who doesn't know the details of your code.
That's really interesting. I actually just did an interview with Kenneth Rice, and he actually is the Python lead at Heroku, and he wrote requests and records. And requests is a HTTP library for Python, and records is a SQL library. And his whole kind of pitch is writing code that humans can understand a little bit better. And I love that idea of maybe there's a man page. Here's a pitch for someone out there who wants to start a open source thing. Write human instead of man, and hopefully somebody will take that and do something better with it than what I just did. But the idea of having a more approachable introduction to the whatever the thing is that you've built is such an important piece of this puzzle. I end up Googling the thing when I don't understand the man page.
Exactly. And I think there's a famous XKCD joke, which is, someone puts you down in front of a terminal and they say, the world's going to explode unless you can like untar this file without any errors on your first try. It's like, I'm sorry. I'm so sorry. Yeah,
XCVFZR.
geez. Oh, is it going to be in the current directory or like, and boom, like, yeah, exactly. And it's like the fact that, and I probably use it, I don't know, every other week, and I still have to Google. I have little snippets because I have to remember, oh, here's all the parameters. Exactly. So making that easy for people, I think I mean, the thing is the code is written once, but it's used, a million times. So it's really the usage use case that we need to worry about.
Yeah, I totally agree with that. The second question, if you could choose a topic for people to talk to you more about, what topic do you wish more people would ask you about?
Good question. Probably maybe the connection between math and programming in terms of the things that programming does right that math can do right as well. So I feel like math, it's evolved with a lot of kludges and the notation and things. There's a lot of old school, like it hasn't really been refactored. And so there's a lot of, it would basically, imagine if COBOL never went away and we've just been like added,
just staying with COBOL this whole time.
Exactly. And there's more libraries and more COBOL. And we've got like COBOL 95 and COBOL 2015. Like we've got like new features, but we haven't really necessarily like really had like a new language and things. And I feel like in math, like in calculus, a lot of these subjects, they're hundreds of years old and the notation has evolved a little bit, but it's still fundamentally using these older systems. And it would be really neat to say, hey, programming, it's a new field, but we've kind of really made things a lot better. And so how can we take those lessons and bring them into the math world as well?
I've always wanted to see equations kind of notated as pseudocode.
Exactly.
You said that earlier and it struck a chord with me because I really do want to get more into kind of a better basis of mathematics for my job, right? I would love to understand more of this. My biggest hurdle is how do I understand what this notation is saying? And I'm having to try to climb back into my brain back from when I was in high school to remember what all these notation things are. And it's not descriptive. And often even in the plain language description beneath the notation where they tell me what all those different pieces are, I had to go and figure out, okay, is this a special value like E, for example, which I know is a special value, but maybe there's like 3 or 4 others in there that I'm just not aware of.
Exactly. Oh yeah. Even conventions, like, is this a constant or is this a variable? Is this a function? And like, there's little hints, like, is it a capital letter or lowercase letter, or is it in italics? But there's all these, like, it's kind of really kludgy. It's not like a strict definition, or there's no compiler really that like,
right.
That can give you the rules and things. And so, yeah, it's really kind of contextual in some ways. And it makes it more difficult than it has to be.
Yeah. I think one of the most effective things that's like kind of stuck with me throughout all these years is SOHCAHTOA.
Exactly. Yeah. And there's ways to we've developed shortcuts and little mnemonics and things. And I think we need more of that. We need to kind of embrace kind of the ways that actually work. And my general approach is, if it works, do more of it. If it doesn't work, try something else, and just kind of keep this A/B test math teaching, A/B test.
Yeah, sure.
What works, what's actually sticking, and just keep going with it.
Yeah. I love that. Well, Kalid, thank you so much for joining me on Developer Tea. I'm sure there are many people who are listening who have been appreciative of your time, and I certainly am as well.
Thanks so much. This is great.
Thank you so much for listening to today's episode of Developer Tea, my interview with Kalid Azad. Of course, if you missed out on the first part, go back and listen to that at spec.fm. Every episode of Developer Tea is available at spec.fm. If you never want to miss out on another episode of Developer Tea, go ahead and subscribe in whatever podcasting app you use. That ensures that you are notified whenever a new episode comes out. And that happens pretty often on the show, 3 times per week. So go ahead and subscribe so you don't miss out on future episodes. If you're enjoying Developer Tea, make sure you leave a review in iTunes. This is the most important way to help other developers find Developer Tea. Thanks again to today's sponsor, DigitalOcean. They are the fastest growing cloud infrastructure provider and for good reason. Go and check out DigitalOcean. Of course, you can use the code DeveloperT to get a gigabyte droplet for free for an entire month. Just for Developer T listeners. So go and check out DigitalOcean, especially if you're looking for a cloud infrastructure provider. But even any developer really can get a good use out of DigitalOcean, and keep it in mind for the future. It's a great platform to keep in mind for the future of your development projects. Thanks so much for listening to Developer T. Again, remember, you can always reach out to me directly at developerT@gmail.com, or you can join the Spec Slack community by going to spec.fm/Slack. I'm in there, and every other host from a Spec show is in that Spec Slack community, and we'd love to hear from you. Thanks so much for listening, and until next time, enjoy your tea.